going to start by reviewing a little bit. Something from a few lessons ago. A few lessons ago, we talked about medians. So we're going to review for just a second. In a minute. What was it when we drew medians of a triangle? It was something related to a centroid. Yes. What else?
From an angle to the opposite side.
Okay, so can I say a vertex? So she said angle. A vertex to the opposite side. Opposite side's middle or the midpoint. So median, we drew from the vertex to opposite midpoint. Logan said something about a centroid. How is a centroid related to this? They all go through the centroid. They connect. All three medians intersect at the centroid. And I use the word concurrency, point of concurrency. Point of intersection or concurrency. I'll use both of those words. That's the first one we talked about. There was a 2/3 rule and all kinds of things. You have a theorem about the centroid. Okay? Intersections. Next, we talked about the altitude. We drew an altitude in a triangle. What did that mean we were doing? What does altitude mean? How high? If you're at an altitude, it's the height. If you have a triangle, it's the height of the triangle. Okay? So an altitude was from the vertex to the opposite side. But we didn't care if it went through the middle, that it had to hit perpendicularly. I'm not going to write perpendicularly. I'm going to write opposite side at a 90-degree angle. We're at a right angle. Use less words. Vertex to the opposite side at a 90-degree angle. That was the altitude. And when we drew all the altitudes in the triangle, they intersected at a wonderful spot also. Does anyone remember? I'll give you a hint. It starts with an O. Starts with an O-R. The orthocenter. The orthocenter was where the altitudes intersected. Something we said with the medians and the centroid. Will the centroid always be inside the circle, inside the triangle? Yes. But will the altitude, will the orthocenter be inside all the time? No. It can be. If it's acute, it will be inside. If it's an acute triangle. If it's a right triangle, it will actually be on or at the right angle. This is the orthocenter. And if it's an obtuse triangle, I don't know if you remember all those little dotted lines that went out and it looked like a big kite. If it's obtuse, it will be outside the triangle. So that's a good question. Where would the orthocenter be located out in an obtuse triangle? It would be located outside the triangle. There was a homework question. Where is the orthocenter located in a right triangle? Where is it located? It's at the vertex of the right angle, or at the right angle. Okay, these are good questions. Now I will go backwards and say the centroid is always inside. Okay. We're going to now add two more of these things to our list. We have two. We have medians and we have altitudes. And each one has a point of concurrency. We're going to start with angle bisectors. There's not a blue word in your lesson about angle bisectors because we've already defined it. What in the world is an angle bisector? It divides it in half. What is everybody knows what bisector means. It cuts something in half. So an angle bisector, go ahead and go. An angle bisector. An angle bisector, I probably should put of a triangle, is a segment that divides an angle into two congruent angles. Two congruent angles. How many angle bisectors do you think we could draw in a triangle? You can draw three. Now, I'm not going to get greatly specific with pulling out a protractor and measuring the angle and then making sure I divide it in half. I probably should to know that I cut it in half. But my board is not 100% calibrated. So we're going to take and see. That means it's not calibrated because it didn't. I put my finger at the dot, but it didn't show up right at the dot. So I got to go a little below. Not that far below. Why? That's close. Now I kind of got to decide where to put this line. Where I cut it mostly in half. Do we feel pretty good right there? Ish. A little up. Oh, I totally just moved the whole triangle. If I just moved the triangle to fit my line. That's not what I did that I want. Do I need to move this? Okay, we're going to agree a little bit that that angle equals that angle. Okay? It's hard to do. Is that enough? No, I need to draw another one. I'm just going to leave them all green. It'll be okay. Go from the top. Ooh, watch out. I landed right at the vertex. That doesn't happen. Hasn't happened to me today. I've done several of these. Ish. Do I need to change that one? A little to the right, a little something. Okay, this one a little to the right.
A little, whoa.
I gotta get a little dramatic.
Right. Nope, left.
No.
Yeah, that's good. Right.
Ultimately, moving it doesn't even hardly change it unless I move it dramatically at the top. Ish.
Right.
A little bit more to the right.
Pretty close? Yeah, ish. All right, last one. Did that work out? Can you see this angle over here? This half the
You need to
room?
go down. You need to go down.
Go back up. Go back up. Right there. Right there. Right there. No. There you go. Stay right there.
Stay right there. Okay. That one is perfect. So ultimately, this angle should equal that angle. And this angle down here should equal this angle down here. And what do you notice about those angle bisectors that we've drawn? What happens? Do they all intersect? It has a different word. Medians intersected the centroid. Altitudes intersected the orthocenter. Angle bisectors intersect at an in-center. I know, more words. Okay? The in-center is the point of concurrency, or the point, point of intersection or concurrency of the angle bisectors. So when they all meet, they meet at the in-center. Does anybody know what it means to inscribe something? To inscribe. You know, you scribe is right, but when you inscribe, like you carve something into, okay? You can inscribe shapes inside other shapes. So the in-center is actually the center of a circle that can be inscribed in this triangle. What? I'm going to say it again. The in-center is the center of a circle that can be inscribed in this triangle. And guess what? From the in-center, going down these angle bisectors will all be congruent and will be the radius of that circle. Now, I'm going to try it, and it's not going to turn out perfect, so just be prepared, okay? So there's a point. We'll go ahead and start again.
That's not right.
Oh my.
I told you it wasn't good.
Get a circle shape. See if you can make it.
Miss Evans. Oh no, you have to redo that.
Not drawn the scale. Okay, well, what?
Oh really? Why?
Would you like to come draw it?
Oh god.
Oh, Carter. I believe you.
So bad. It looks the same.
Perfect. I think I'm better. Everyone,
To me, it looks like a face. That
It looks like a face. It's a circle.
Everyone take a chance of drawing a circle.
No, we don't have that kind of time.
Yeah, Kate, you get it perfect.
Kate,
Don't
go.
put that burden on me.
Kate, go.
Don't you embrace that.
The issue is,
Kate.
could I?
Okay, well now you gotta go. No. That doesn't even look like
You can make it look better. You can make it look better. I can't even see it. The
Kate
erase
can
card
do
is
it.
terrible.
Oh no. I've got a little onion.
Miss Evans. What happened to me?
I keep touching the wrong thing.
Just give up.
Okay,
Can you expand, sir?
I can.
Let's try.
Hey, that's it.
I didn't really mean to do that.
Kate can draw a really good circle. Kate can
Miss
Evans. I think you
No,
stopped.
you can do that. Look at that. Okay, that's not what I intended to do. Okay. We're gonna move it.
Miss Evans.
No,
A little bit over.
You see
Shoot it
the
now,
left?
just a little
You
bit.
see the top left and the top right. They're both.
Miss Evans.
Go to the
Miss Evans.
No.
Like the man with the broken thumbs.
Looks like a water wheel.
No.
No, I'm right.
Yeah, no, with the cats.
Wait, with the thumb or left hand?
With the, no,
Would you like me to move
with
the circle?
No, I want to see if I can trace the circle.
Oh, you're gonna change the circle. And then
Oh.
point.
Okay.
Okay.
Alright,
Big
you're
shot.
gonna pencil. Alright.
Okay.
Is it ready? What?
It's not calibrated perfect.
We should calibrate.
Yeah, we
It's even, I've calibrated it like
Oh
a bunch.
That is.
Okay, ultimate goal. The center of that circle to the edge is the same distance. Yes, it is. We start with drawing something else. We drew medians, vertex to the midpoint.
It's 200.
Okay. We did that first. The second one, we drew vertex at a right angle, straight down, not midpoint. This is the third one. We're only bisecting the angle. We don't care about where we hit the other side, if it's at an angle or the midpoint or anything. Okay? So they're a little bit different. So maybe this word is, well, what if you have that regular normal triangle? So if we had an equilateral triangle, all four, so we're gonna do one more, would be the exact same point. So they could all be the same. They don't have to be.
Logan, you already did that part.
Okay.
Okay.
Yeah.
One more time.
Excellent.
That was perfect.
Okay. Now,
That was perfect.
what you need to know, what they will ask you is if this is 5, what is X? 5. It's the center of the circle, meaning that radius will be the same. Do you have a question?
Can I try again?
No.
Yeah, you drew that. You drew one of these.
Okay.
I did
So-
my left hand.
So ultimately, that's one thing you need to know. There's something else you need to know about the incenter of. Oh wait, I don't want that.
Oh, Miss Evans, that's not straight.
But it is because I use straight lines on purpose.
I mean, like, it's tilted.
That's okay. That's okay. All right, so now I'm gonna get.
Oh, no.
I know. I'm gonna change it. I'm gonna change it.
Miss Evans.
First thing I'm gonna
No,
change
you gotta
is
move it.
where is it at the vertex? Now,
Right.
Left.
Oh,
No.
no.
Right. Right.
Not a little bit.
It's
I
never
think
gonna
it
be
needs to
perfect.
go.
never gonna be perfect.
It's
No,
like
we're having it.
it's just left off the vertex. I think that's good.
Thank
A
you.
little bit to the right.
Okay.
I think you need to do triangle.
All right. If we have bisected this angle, there's a theorem that says it will intersect or divide the side proportionally to the sides you're given. Okay? So what does that mean? If I give you, this is a length of 20 and this is a length of 18. I give you this length is 10. One, oh, no, let me not do 10. Let me do 9. No, let's not do that. That's not nice. Let's go, that's 2 9s. Okay? So theorem 38-1 says, if a line bisects an angle of a triangle, what we just did, we drew an angle bisector, then it divides the opposite side proportionally to the other two sides of the triangle. Okay? So how in the world would we solve for x? Would x simply be 11? Did we cut it in half?
Oh.
No, it is not. It is not a midpoint. It's not a median. Yes, Carter, what are we gonna do?
You do the thing for one triangle. So like 11 squared plus b squared equals 18.
You know that's a right triangle already?
Liar.
You assume, you made an assumption that there's a right angle somewhere.
Am I not allowed to assume?
No, you are not.
Sorry.
You can't assume this. Go ahead, Anna.
I would add the 11 and 18 and then subtract the difference. No, sorry.
Is it a right triangle?
You would add those two and then subtract 20.
Okay, so the theorem that we just read, does it matter at all?
Yes.
Yes, it says it divides the segment, the side length, what? There's a big word there. Really? Really? Read theorem 38-1. Where does it say it?
Read it.
Proper relationship. Yes.
It divides the opposite side what? Proportionally.
So you would add the 11 and the 18.
What does it mean to be a proportion?
A ratio.
A ratio.
Oh, yes.
A ratio of
Got
what?
it right.
X would be.
Math numbers.
Can I say it?
I don't know. What did you, I want to see a formula. 20.
Formula. Okay, what about
Okay, I don't have this answer in my head. What did you get? Repeating decimal?
Oh, I mean.
Can't be. Alright. Right now, knowing an answer doesn't help. How do we get there? It says it divides it proportionally. Logan said that I need a ratio. What ratios do we need?
X over 18.
20 over 18.
X over 11.
X over 11. Wait, Miss Evans. I set it up as 20 over X equals 18 over 11. Did I do that incorrect? No. Why?
It's just the opposite.
20 times 11, 18 times X. 20 times 11, 18 times X. You have to set up a proportion. Okay? Ultimately, 18 is shorter than 20. So 11 has to be shorter than X. That's a logic. Okay?
So, and 18 is 2 less than 20, so X should be 2 less than 11.
That's not how proportions work. You have to cross multiply. 20 times 11 is 220. Equals what? 18x. And how do we divide? How do we solve for x? 220 divided by 18. And you get what? 0.2 repeating. Okay? Yeah.
So repeating is okay.
Repeating is okay unless you want to put 2 ninths. 12 and 2 ninths is what it is.
Oh. We don't.
12 and 2 ninths is the same thing if you just reduce. Okay? You have a question. It can't be just this is 2 less and that has to be 2 less. That's not how proportions work. We need to do another one.
Yes.
All right. Yeah, okay, I'm not going to do that. Okay. I'm not going to do what I was thinking. Oh, that looks too nice.
It was very nice.
It was very nice. Now I need an angle bisector. not starting off in the corner. Really not starting off in the corner. And then we're just not going to care anymore.
We have to care.
Ultimately, the time wasted is only going to hurt you. Only going to hurt you. I'm sorry. So we're going to say this angle is congruent to that angle. Your book even puts a little line on it that says this angle is congruent to that angle if you didn't already know that. Okay? And it says this side is 50. This side is 35. Not drawn to scale. We don't really care about scale. This one is 44. This one is X. You will have this theorem, and it will tell you it divides the opposite side proportionally. How are you going to solve for X?
So whatever, so it's x over 44.
Okay?
Does it have to be 35 over 50?
So do I have to go in the same order? Yes. If you go in the order X to 44, you have to go in this order. If somebody wanted to go 35 over X, then you go 50 over 44. You have to go in that same order, but either one of those orders would work.
You go 44 to x and then 50 to 35.
Yep.
You go cross like diagonal.
35 to 44?
Yes.
No, because it's not related to it. So 35 over 50. We're going to cross multiply. Then we're going to divide. Did you get X equals, what did you get, Logan? 30.8 units. Okay. We need to move on to the last one. Not, we will run out of time. Last but not least, we're going to talk about perpendicular bisectors. Not a blue word, but do you know what a perpendicular bisector is? Okay, bisect, what does it mean to bisect something? Cuts it in half. What does it mean to be perpendicular? Intersect at a right angle. That's important. Okay? Things intersect all the time, but they don't intersect perpendicularly. So this is a segment. That's none of that. That divides. Goodness. I cannot. Divides. That's not what I would say either. Divides a side of a triangle in half. Divides the side of a triangle in half and at a right angle. What's that going to look like? Okay, triangle. So, do I have to find what's going to divide it in half? The bisector. How can I bisect the side of a triangle? What do I need to find? The midpoint. If I want to divide a side of a triangle in half, I need to find its midpoint. Okay? So I'm going to find the midpoint. I did, yes. Because I didn't have coordinates to find the midpoint for the midpoint formula. Then what are we going to do? What does it have to be? At a right angle. Would it matter? No. You're still going to divide it in half, and you're going to take that line and go at a right angle. This is the only one that doesn't have to go through a vertex. Could I find the midpoint of this side? Ooh. At a right angle. I think that the first one I kind of off the midpoint. It wasn't quite the same. This one, ish, make that dot bigger. So this side equals this side. Right angle. Pretty close. Are they going to intersect at a certain spot? Did all three of those angle perpendicular bisectors intersect at the same spot? Yes. Close to it. They will. We call that the circumcenter. You know that you can, I totally misspelled. It's the point of concurrency. Have you ever circumscribed things? You put things around. Okay? So technically the circumcenter is equal distant from all the vertices. It will be equal distance. I'm going to put an I there. Equidistant from the vertices. So, you can draw a circle around the triangle. Okay? You can draw a circle around the triangle. When would we ever need to know this? Pretend I have an amusement park. And I have three of my most famous rides. And I want to put a new restaurant equal distant from all three rides. You know what I'm going to find? Oh, gosh. I'm going to find the circumcenter. Okay? It will be equal distance. All right, wait, before you take off, have a seat. Don't pack up yet. I'm giving you something. I'm giving you early Christmas presents.
Hundreds on this test?
I'm giving you a midterm review. Also, I need you to listen. I need you.
No, sir.
Are you ready to listen?
Yes.
Okay, so I don't want to repeat it 13 times. This midterm review is a list of lessons and topics. Okay? On a separate sheet of paper, you are going to write at least 2 notes about the lesson. It could be definitions, part of your postulates, something that's important about that topic. You're also going to write one in-depth, at least one, you can write more, in-depth question. Something you don't understand about it, but be specific about that math topic. or something you think somebody else might struggle with, a math problem. It could be a problem or it's a question you have. For each lesson, that will be due on Tuesday. Okay? I'm also handing you the review test for 8B. Okay? What you're going to do for test 8B. On a separate sheet of paper, you are going to write out and work all of test 8B. Show me all of your work. Okay? This will be due before class starts on Wednesday. This will be a test grade. We will not have a test on Tuesday. Everybody understand that?
Yes.
Wait. One more thing. For this test, you can use your book, you can use your notes. You cannot use your friends or the internet. Okay, you can come ask me questions. You can ask your mom or dad questions. Okay? You will not sit in study hall and do this together. Okay, it's a test grade. Midterm review will also be a test grade. Okay?